battery energy storage systems have become prevalent with more than 90% attachment rate in states like California. Of course, that would be for the residential sector. And if you go anywhere in Texas these days, you're going to see battery storage systems being deployed even without photovoltaic systems. So how is the commercial industrial sector faring? We're going to talk about that specifically with one of the market experts on the C&I storage space, CPS Americas. I'm joined by CPS America's Solutions Engineer for Battery Energy Storage Systems, Jayson Smith. Jayson, it's good to see you.
Nico, thank you for having me here today.
So the messy middle, as we call it, the C&I, let's call it like over 100 kilowatts, under 5 megawatts, has traditionally been relegated to rooftop solar, and we don't see a ton of battery energy storage integrated. Why do you think that is?
Well, for a long time, you could pretty much get where you needed to be with just, a PV system on the roof, right? You look at California a few years ago, you install a PV array, you're able to sell back to the grid any excess power, make a good chunk of change off of it. Whereas now with the net metering 3.0, you no longer have those revenues coming in. So the battery attachment rate has really increased in order to use all of that PV power to the customer's benefit. And how that's being done is actually through demand charge mitigation.
Yeah.
So that way they can reduce their overall cost.
What are the things that prevent building owners and operators from adding storage naturally to PV systems as they've been deploying them?
Yeah, I'd say there's a couple of different things, but the biggest one by far is going to be footprint.
Okay.
Right. So historically, a lot of those commercial size battery systems have been, somewhat large, maybe a couple of different containers to get the, capacity that they need. And now, thankfully, we're moving to a time when, with the cell technology getting better and better, that energy density, essentially we're able to pack a bigger punch in a smaller footprint. So it's kind of making it a little bit easier for these customers to say yes to the battery, as well as, the incentive side.
What about delivery schedules? Is there any complication there with storage?
Over the past couple of years, we've all kind of seen, delivery schedules just get worse and worse and worse for not only the renewable sector, but also, say, the industrial automation sector. Pretty much across the board, timelines keep getting pushed out for equipment to be on site. There are a few companies out there now, thankfully CPS being one of them, that has some stock, right? But the majority of people in the space, you're looking at multiple months. There's even some people out there that are multiple year lead times.
Wow.
And that's a big hurdle that we have to get over, right?
Yeah, especially when you're looking at payback periods that have historically been longer. Are we seeing the payback period shrink as well for battery storage?
Definitely. So as I mentioned before, with that NEM 3.0 coming into place and those high demand charges out in California, as well as out in Florida, you see some high demand charges here and there. Yeah. That's really where that payback is coming from. Yeah. And we actually, I had a talk yesterday and I did a case study, and the payback period was as low as 3.5 years.
Wow, that's pretty remarkable, actually.
I mean, at that point, you're paying the whole system off before you're outside of the warranty.
And the economics driving that specifically are around demand charges?
Definitely. Demand charge reduction is what we're seeing is it's the number one driver for a reduced payback period.
I know that you all have been focused a lot on driving out costs and to make it more cost effective, to make it something that could be under 5 year, under 3 year, if we can get to it, payback. Where are you seeing savings, particularly around balance of system, what we call BOS in the C&I system?
Yeah, so as I alluded to earlier, those older model systems where maybe multiple cabinets, you have one that's your DC block and then one that's your actual power conversion system. That's going to come with additional wiring that's needed to be purchased, additional trenching, things like that, specialized insulation. Nowadays, with some new systems that have been coming out, they're that all-in-one container. So essentially, whenever you go and you plop it down on site, you've had your pad that's built, and you don't have to worry about any of that wiring for the DC side. All you now have to worry about is hooking up your AC cables, maybe a single Ethernet line to an energy management system. In addition to that, that energy management system controlling everything, and the older models, usually each one individually is running a line to that energy management system. That becomes a lot of lines for comms. Nowadays, we're able to daisy chain these systems, so that way you're reducing the overall amount of Ethernet lines needed.
Amazing. So it sounds like the bulk of the balance system reduction is in the cable, in the communication cabling particularly.
Communication and DC to the PCS.
It makes sense. For those unfamiliar, let's just go ahead and define what is PCS.
So PCS is the power conversion system. It could also be called the bidirectional inverter. So it's what's doing the DC to AC conversion or the AC to DC rectification.
Fantastic. Rectification, another word that is
Yes.
a very engineering word. What does that mean?
Yeah, so rectifying is essentially taking your AC power and then making it into DC power. That's done through diodes, transistors.
I see. So rectifying is basically reversing the inversion.
Correct.
Okay.
Correct.
Okay, that makes sense. I know that I've heard the term rectifier a lot. I don't think I've ever quite wrapped my head around what it means precisely. I want to come back to the footprint because that's one of the main impediments, that being size or space constraints. How have we seen the footprint shrink? Like, what are we talking now in terms of how much space does a typical system for a C&I project take up?
Yeah, so nowadays, I mean, you're looking at less than, 10, 15 square feet, which is actually extremely small compared to, previous systems that, I mean, back in the day, it would be a 20-foot container for, say, 1.5 megawatt hours, which that's a pretty big footprint, right? Whereas nowadays, you can get 250 kW, and like I said, that 10, 15 square foot, footprint, which is extremely small. So small that you could put, a handful of them within like a parking space.
Yeah, so what used to take multiple parking spaces now is a parking space or less. And it makes a big difference. Most companies don't have the luxury of giving up a parking space or the equivalent of a parking space inside of their facility.
Exactly.
Are we at the place yet where this stuff can reliably be placed closer to the asset, up on the roof?
Not quite. So the energy storage system itself, it's in reality, it's too heavy to go on a roof. Right, those cells are packed pretty dense.
Right.
But we'll see in the future. There are a couple of solutions out there that are very small scale batteries that can be put on the roof with special racking.
Sure.
But that hasn't really taken off yet, but we'll see what the future holds.
As an engineer, you have to build products that are code compliant. One of the codes that everyone cares about is UL 1741. There's a special subset of 1741 called CRD. What is it, and why should installers care?
So UL 1741 CRD, it essentially outlines import and export functions for the PCS. How that's actually important for us is, used to whenever you were installing, you'd have to put a reverse flow relay to make sure that you never push to the grid in a non-export scenario. And nowadays, with that UL 1741 CRD, we're able to take that component out in some jurisdictions.
So it allows AHJs to have to not have that physical disconnect, which saves
Saving
on
money.
balance of system.
Yep.
But how does it address the safety concerns that the physical disconnect was responsible for?
Yeah, so that's all done through smart control, right? So essentially, through the energy management system, it's able to verify that PCS is not going to push out. And the PCS also has to meet certain millisecond requirements.
It's interesting, right? Because we had these requirements because we didn't have the software sophistication that battery energy storage systems have necessitated.
Correct.
How interesting. Jayson, one thing I know that you guys are working on a fair amount, in particular, serving the additional needs, we'll call them non-obvious loads perhaps, of building owners that help your installers sell these systems even more cost effectively. How do we reduce the payback of these non-obvious battery loads and with the software controls?
Definitely. So that's going to be with the energy management system, and a couple of ways that it can perform, some additional cost savings for the customer would first and foremost be HVAC load control.
Right.
So with that functionality, we can essentially make a thermal battery that's equivalent to about a 1.5 hour BESS, and that automatically gives you, a lot of cost savings every year. In addition to that, you can be set up with a couple different locations as far as demand response, and also make a little bit of extra money that way. And that all, accumulates together to get you an extremely, extremely fast payback.
So it sounds like having the proper energy management system. I know that you guys have partnered with a very specific company that offers a variety of different load controls allows you to take advantage of the battery energy storage system beyond just storing and harvesting solar power and releasing it for sort of load shifting, et cetera. You're able to optimize things like time of use or EV charging stations, even demand charge reductions, I'm sure is part and parcel.
Correct. And all of that accumulates together to really, give us the most bang for our buck for the customer.
Jayson, as we wrap, I have a final question for you. What's something most installers don't know about battery energy storage systems and the market in which they operate that you really wish they did?
Yeah, one of the biggest ones I would say, there's a lot of white labeling going on.
Yeah.
Yeah, so there's a handful of actual manufacturers out there, and everybody else is just white labeling their products. So I'd say it's very pertinent for somebody to go and actually find that manufacturer, because what that allows is it allows for that direct communication and that better support.
Jayson, you guys have done an incredible job serving the C&I market. I'm encouraged to see how you are not just reducing costs, but reducing complexity for installers along the way. Thanks for coming and sharing insights into all of that information. How can folks find more about CPS and get a quote if they want for your batteries?
Definitely. The best way would be to go to our website, but you can also contact me directly. My email is Jayson, JAYSON, .smith, SMITH, @chimppower.com.